Hello students, in the chapter Introduction to Trigonometry, let's solve 11.4 in this video. Before solving, let's learn the trigonometric identities. An equation is said to be a trigonometric identity if it contains trigonometric ratios of an angle and satisfies it for all values of the given trigonometric ratios. So, the trigonometric identities are sin square theta plus cos square theta equal to 1. So, this can be rewritten as sin square theta equal to 1 minus cos square theta, or we can write cos square theta equal to 1 minus sin square theta. Then one more identity is cosecant square theta minus cot square theta equal to 1. So this can be written as cosecant square theta equal to 1 plus cot square theta, or cot square theta equal to cosecant theta minus 1. Secant square theta minus tan square theta equal to 1, or secant square theta equal to 1 plus tan square theta. Tan square theta equal to secant square theta minus 1. Then sin theta into cosecant theta equal to 1. You know that cosecant theta is equal to 1 by sin. Okay, so that's why if you multiply sin theta and cosecant theta, you will get 1. Cos theta into secant theta equal to 1. Okay. Why? Because secant theta equal to 1 by cos. That's why we are getting 1. Tan theta into cot theta equal to 1. Because cot theta is equal to 1 by tan. That's why we are getting 1 when you multiply tan theta and cot theta. So with these identities we can solve the exercise 11.4. So first problem, express the trigonometric ratios sin A, secant A and tan A in terms of cot A. So we have to represent sin A first in terms of cot A. So we know that cosecant square theta minus cot square theta equal to 1. Okay, so we are choosing a identity where you can relate sin and cot. Okay. So if you see in this identity, cosecant square theta, that is 1 by sin square theta you can write. Okay, and cot theta is already there. So you can somehow relate sin theta and cot theta. Okay, so here we can write it as 1 by sin square A equal to 1 plus cot square A. Okay, here in question it is given A, so we should also use A. Then sin square A. Okay, so this is taken to the numerator. So this here, the other side of equal to will come to the denominator. So sin square A equal to 1 by 1 plus cot square A. So we want sin A, no? So take root on both sides. So you will get sin A is equal to root of 1 by 1 plus cot square A. Okay, so root of 1. So when it is division, you can take root separately for numerator and denominator. Root of 1 is 1 only. So 1 by root of 1 plus cot square A. Then in the same problem, we should find out for secant A. Okay, secant A we have to find out. So this identity we are choosing. That is secant square theta minus tan square theta equal to 1. Okay, so secant square theta equal to 1 plus tan square theta. Okay, so you can write tan in terms of cot. So in the place of tan it is written as 1 by cot square theta, cot square A. Okay, so now take the LCM. Here you have 1 and here you have in the denominator cot square A. So the LCM will be cot square A. So this cot square A should be multiplied with the numerator 1. So 1 into cot square A, it is cot square A only, plus 1, that this one, okay, plus 1 whole divided by cot square a. Okay, so we want secant a. Okay, now it is in square, you want secant a, so take square root on both sides. So square and square root will get cancelled, so you are getting secant a. Then this side RHS take root. Okay, so this root in the numerator and denominator we can separate it. So what you will get, root of cot square a you will have in the denominator, root of cot square a. So root and square will get cancelled and you will be left with cot a. Okay, in the numerator you can't do anything because cot square a plus 1 is there. So you can't take square for this one, square and square root you can't cancel. So write as such. Then last one, tan a we have to find out. It's very simple because in terms of cot we have to represent. So tan a equal to 1 by cot a. So that's a final answer. Second problem, write all the other trigonometric ratios of angle A in terms of secant A. So how we did in the previous problem. Same way we have to represent all the ratios in terms of secant. So sin A, cos A, tan A, cosecant A, cot A. So these we should represent in terms of secant. Okay. So first identity we are taking, that is sin square A plus cos square A equal to 1. Okay. So in that we want sin no, so bring, okay, you leave sin in one side of equal to, bring cos square A to the other side of equal to, so it will come in minus. So cos can be written as 1 by secant square A. Okay, cos square A equal to 1 by secant square A. So it is written like that. So the next step, take LCM. So after taking LCM, this secant square A will be multiplied to this numerator. So you will get secant square A minus 1 the whole divided by secant square A. Now we want, this is sin square A. We want sin A now. Next step, take root of the RHS. Okay. So in the denominator, why the root is removed means you have square here. So root of secant square A. So root is also there, square is also there. So that will get cancelled and you will get secant A alone. Okay. In the numerator, you can't do anything because secant square A minus 1 is there. So you can't remove the root, so leave it as such. Now next, cos A. What is cos A? Cos A is 1 by secant A. Okay, so that is the answer because it is represented in terms of secant A. Then tan A. Tan A, what is tan A? Sin A by cos A. Okay, just now we found out what is sin A. So substitute those values. In the place of sin A, what we found first, that you write. And in the place of cos, that is 1 by secant, that you should write. Okay. Now what will happen? Here also denominator secant A, here also is denominator secant A, that will get cancelled. So you will get root of secant square A minus 1. Okay. So that's the final answer for tan A. Next you have to find out for cosecant A. What is cosecant A? It is 1 by sin A. Now, just now we found out what is sin A, no? So that you have to substitute it in the place of sin A. Now it will come like this, 1 by root of secant square A minus 1 by secant A. Now take this secant A to the numerator. Okay, so you will get like this, secant A divided by root of secant square A minus 1. Then cot A. Cot A is 1 by tan A. So tan A just now we found no in the previous slide. So substitute that value. That is 1 by root of secant square A minus 1. So that's the answer. The third problem, evaluate sin square 63 plus sin square 27 degree divided by cos square 17 plus cos square 73 degree. Okay, so in the previous exercise what we did like sin 90 minus theta equal to cos theta we did, no? So that we are going to use here. Okay, first step is we use the things which we learnt in the previous exercise, that we will use here. Then we will bring it to the identity and we will simplify. Okay. So first, this is the given problem. Then I'm going to write sine square 27. Okay. So 27, I'm going to write it as 90 minus 63. Okay. What is sine 90 minus theta? It is cos theta, no? So in the next step we can write like that. And here here 17 is written as 90 minus 73. Okay. So the next step I will write like this. So sine square 63 degree plus cos square 63 degree. Okay. So this one only. Okay. So this cos square 63 degree, because it is square. So don't leave the square. You should also write the square. Divided by sine square 73. Okay. So this cos 90 minus theta will be changed into sine theta. No. So sine square 73 you will get here. Okay. So here now you apply the identity. Sine square theta plus cos square theta equal to 1. You remember? So here also sine square theta plus cos square theta equal to 1. If you see here, theta value is 63 in both, and here also 73 in both. Okay. So this can be used with the identity. So we will get 1. 1 divided by 1 we will get, so that is equal to 1. Okay, actually you should write the identity here. I have not mentioned here, so you write it. It is sine square theta plus cos square theta equal to 1. With that identity we are getting 1 as answer here. The next problem, sine 25 into cos 65 degree plus cos 25 degree into sine 65 degree. Here also same way, use the complementary angles. Okay. So that we have to use and we have to simplify. So cos 65 will be written as cos 90 minus 25. Okay. Similarly, here also sine 65 is written as sine 90 minus 25. Okay. So in the next step you will get sine 25 into sine 25 plus cos 25 into cos 25. So what is this? Both are same in multiplication. So you can write it as sine square 25, no? And here also cos 25 into cos 25. So it is cos square 25. Okay. So sine square 25 plus cos square 25 equal to 1. Okay. So both are same angles. Okay. Both are 25 degree. So it is sine square theta plus cos square theta equal to 1. That identity we are using and we get 1 here. Choose the correct option. Justify your choice. So first subdivision is 9 secant square a minus 9 tan square a equal to what we have to find out. 4 options is given. So let's solve. So option B is correct, and justification, let's see. Take 9 outside. So you have 9 in common for both. So 9 is taken out as common. So you will be left with 9 into secant square a minus tan square a. So using the identity. So secant square a minus tan square a equal to 1, no? So by using that you will get 9 into 1 equal to 9. Okay, so that's why we are getting the option B as right answer. Okay, so with this I'll wind up this video. I'll continue the same exercise in my next video. Thank you, children.